Okay, so here's another calculator example. In this case, we want to solve the given equation or inequality graphically. So that essentially just means where do the y values agree? At what x makes the two functions equal? Meaning what x makes their outputs or y values the same. Okay, so to do this, I'm just going to enter both functions in the calculator. So my first function is x to the third. Make sure to move out of the power. Plus 8x squared. And that's it. That's my first function. Okay, enter. My second function is negative x squared. For negative, make sure to use the negative symbol, not the subtraction. So negative of x squared plus 7x plus 2. Enter. Now, if I hit zoom standard, I'm going to get a standard graph, and maybe that'll work, maybe it won't. Okay, so I'm kind of seeing some intersection points here. Okay, but we kind of want to zoom in on that area. Now, the zoom in option, the problem with that is it zooms both dimensions the same. Okay, in this case, I just want to look narrower, so instead of going negative 10 to 10, maybe I'll go like negative 5 to 5 in the x, and in the y direction, I want to look higher. Okay, so I'm going to hit window. So for my x, I'm going to look negative 5 for the min, 5 for the max. And for the y, I just want the y max to be higher. Let's try maybe 20. Okay, let's see what the graph looks like. Okay, that's a little better. So I'm seeing two intersection points. Notice I have a lot of hash marks on the y-axis. If that kind of looks a little bit objectionable, you can make the y hash marks bigger. So that's the scale. I can make the scale instead of 1, I can make them worth like 5. So each hash mark's worth 5 now. So it's a little prettier now. Okay? But I want to see where these intersection points are. So I'm going to use the calc tool. Second, calc, intersect. Now, it's going to ask me to identify the two curves, which is kind of weird, but quite often we use this intersect function when there's lots of functions being graphed. And so if there's like 5 or 6 functions on the screen, then which two am I trying to intersect? That's what we are being asked for. Now, if there's only 2 functions, yes, the calculator should know it's just 2 of them, but still it goes through the steps. So it wants me to verify, is this the first function I'm interested in? Yes, enter. Is that the second function? Yes, enter. Now it wants a guess. It wants me to put the cursor as close as I can get it to the intersection point and hit enter. Okay, and so they're going to intersect at the x value is negative 0.223233, and the height is this 0.387 number. Now, the 387 is not that important. What we're looking for when we solve a system of equations is the x that makes the two functions equal, the input that causes the two functions to be the same. They're the same because they both have the same height, but it's occurring at this x, so the x is the solution. Okay? Now, can we find the other intersection point? Sure. Second function, calc, intersect. It's going to ask me to identify the curves. I just want to make sure I'm seeing the two curves so I want to go to a place where the two curves are separated a little bit. Now I'll identify the first curve. I'll identify the second curve, and now I'll move closer to the intersection point for the guess. Notice for max and min, you needed to put left bound and right bound, but for intersection, you don't. You just have to identify the two functions and then put the cursor near the guess point and then hit enter. And there you go. Okay, so there's the solution to the system is right there. Okay, that number, that x value makes both functions have the same height. The height happens to be 7.612 if they ask, but the solution is the 0.9236. All right? All right. Okay, so our last step really should now be just to kind of move back out and make sure there's no more solutions way out here or way out here. I mean, it's possible. Okay, so in this case, I'm just going to use zoom out temporarily, even though I'm not crazy about it, because it does zoom. The problem is zoom out zooms in both directions simultaneously, which is a little bit problematic, but do I want to zoom out around that solution point? I'd rather zoom out roughly around 0, 0. So I'm just going to tell it to zoom out around the origin. I'll just kind of try to get close to there. I'm going to zoom out around that point. Okay, and they might be crossing out here somewhere. Let's zoom out a little bit more. Okay, or in fact, how could I look in this region over here? I'd need to look further to the left and further down. Okay, so let's go to Window. And I want to look further to the left. Right now I'm looking at -20. So that's probably far enough. I just wanted to kind of, we were only going to -5, so that's why we weren't seeing this stuff out here. But let's kind of look out. We're already going to -20. That's far enough. I do want to look further down. So for Window, let's do the Y min lower. So instead of -58, let's try -100. Notice when you do zooming, it kind of sets weird Y mins and Y maxes and X mins and X maxes because it's a computer program doing that. So it sets weird values. But let's go ahead and do that. Let's go ahead and make the min a little bit lower and graph it. Okay, I think I still need to go lower. So my Y min, let's try -200. Notice at this point my Y scale is probably not going to be sufficient because I've got roughly a spread of 260 units in the Y direction. So that's going to, with each Y value being worth 5, it's going to be too many little hash marks. It's going to make the axis not clear. So I'm going to make the scale worth more. So instead of 5, let's make it worth like 10 or 20. I'll do 20. Okay. And now let's graph it. Okay, So there is another point where they're crossing out here. That's interesting. So how do I find it? As long as you can see the crossing, we can use intersection. So second, calc, intersect. And is that my, so for first curve, second curve, I'm just going to move out here somewhere. Enter to identify the first curve. Enter to identify the second curve. Guess. Just kind of get close. Enter. And there we go. Okay. So around -9.7004 would be the solution. Okay. It causes both functions to have roughly -156 as the Y value. Okay. Pretty cool, huh?